Welcome to another tutorial in the Unreal Engine series. In this video we will learn how to use the linked animation graph. Let's start. When we work with animation blueprints, it is very easy to start adding all kinds of animations and states depending on our objectives. For example, the traversal part, add the animations of climbing, jumping, falling, moving, swimming, among others. The list can become endless, and unfortunately it is not allowed to work on the same file by two or more people simultaneously. To solve this, you need to use linked animation graph. First of all, we can have several animation blueprints linked with the main ABP. For this and for demonstration purposes, we will duplicate the ABP_Mani and rename it ABP_Mani_locomotion, whose logic will be controlled internally in this blueprint. To exemplify, we will remove all animations and assign only run_forward. We will duplicate ABP_Mani again, and rename it ABP_Mani_idle, which will control the animation state of the torso. Again, we will remove all animations, and assign only the MM_idle animation. In the main animation that we want to extend, we will create the linked animation graph. Opening the animation graph, we can right-click and select Linked Anim Graph. We will save the output value of this block, using New Save Cached Pose. If we select this block, we can change the name of the created cache object. We will select the linked anim graph block, and in the details part, we will assign the ABP that we created for the locomotion, ABP_Mani_locomotion. Repeating the steps, now for the ABP_Mani_upper body. To control the animation state, and define which animation blueprint will have to take control of the character, we can use the layered blend per bone method, whose input parameters are the main pose, the secondary pose, and the weight that each of the input will have. We will assign the entries to those stored in the locomotion and upper body cache, just like we did earlier. Taking into account that 0 means that the final animation will be 100% the input of the main animation, while the value 1 will be 100% the secondary animation. If we use intermediate values, we can combine both animations to have a mixed result. Finally, and to conclude this example, we can prevent the blending of the animations from being bone to bone, using the filter, branch filters. We can assign that it is only mixed from a certain bone. For this example, I will use the bone of the hierarchy, spine_01. Once it is compiled, you can see the final result, showing 100% the run animation, or the mix between run and idle. Hit that thumbs up button, and subscribe for more Unreal Engine content.